In this video, I'm going to show you how to install Cellpose to be used with QuPath or Fiji. There are many ways to do it. I'm going to show you one that is not too difficult to do and that should work with any environment. Cellpose is coded in Python, so first we need to install an environment that let us install a Python code. To do so, we're going to install Anaconda 3. So I'm going to open a web browser and you can type in Anaconda download and you should have something for Anaconda. So if I go to the main link, alright, so here there's a link to download the distribution, and I'm using Windows and so it's already the right version, so I'm going to download it. And I'm going to speed up the downloading time so you don't have to wait for it to be done. Alright, download's over, so I can open the file. And it asks me if I want to install Anaconda, so I'm just going to go next, agree, next. I'm going to install it in my user folder. And I'm going to install it just with the regular options. So again, I'm going to speed up the video so you don't have to wait for the entire installing time. Alright, it's down, so it's a bit misleading. It goes very fast up to almost the end and it takes a little bit of time, but that shouldn't be too long. So now I can just go next and finished, and I don't want to have a tutorial or anything. I'm just going to finish it. Now that Anaconda is installed, we could install Cellpose, but we want to install Cellpose with the GPU, so we can use the GPU to run Cellpose. So first we need to install CUDA toolkit. So I'm going to go back to my browser and I can type in CUDA and I want to install 11.7, and there's a link to the download directly in here. So you need to define which operating system you're using. So it's Windows 10 for me, and I'm going to use the executable on the network. So then you can directly download the executable to install CUDA. And now, to do that, alright, and then it asks you where you want to put it. Just, keep it the regular one, it's going to be fine. And then you have an installer that is checking everything on your system if you have what you need. So then you can just go through the different questions. So I'm going to keep going. Alright, so you agree on the license. Express is fine. So it's preparing the installation. Just one thing, so it's possible that it won't work if you haven't installed C libraries. So if it's the case and you're using Windows, you can just download the Visual Studio, but the community edition is fine, so it's free and it's going to install the libraries that are required to run CUDA, and then it will work fine. So if you don't have this, it's gonna stop and tell you that you don't have C libraries. So just install Visual Studio, make sure you have the C checked in, and that will be fine. So I'm gonna now speed up video, so you don't have to wait for the entire installing time. Just gonna click next. And now it's all over. I'm gonna close it. And I can close it. Alright. So next step is to install Qt. So I'm going to go back to my browser. And now, still in NVIDIA developer website, I'm going to look for QuPath. So the only thing is that for QuPath you need to be logged in. So if I go there, it's going to ask, so no, it seems to be fine. Let's check this out. Yeah, so you need to log in. All right, so I'm going to log in. If you've never logged in, you're going to have to actually create an account. It takes a little bit of time, but it's fine. It's okay. And then you can download QuPath. So you have to. There's no other way to do it, unfortunately. So you can then agree. And I'm gonna actually, so here you have the QuPath for QuPath 10.2 or 11.x, so, and you have archived. So we have the 11.7, so that's gonna work. And then just gonna open, so we're gonna download it for Windows. So we're gonna download the zip file. And again, I'm gonna speed up video, so you don't have to wait for the entire downloading time. Alright, so now I can reduce this. I'm gonna go to my download folder here, and I'm just gonna copy this on my desktop and zip it. Alright, and now as you can see, it's only folder. You have a bin, an include, and a lib folder. If you go there, so here you have QuPath.dlls, QuPath.h, and QuPath others.h, and the lib here. So I need to copy these files in my QuPath toolkit folder. So most of the time, if you install it with the regular path QuPath on Windows, if you go on your C drive and on programs, you're gonna have something which is called NVIDIA GPU Computing Toolkit, QuPath, and then you have, so here I installed the 10.1 before and the 11.6. Now we just installed the 11.7, so that's the one I want to finish to install. If I go there, as you can see, there's also a bin, an include, and a lib. So what I'm going to do, I'm just going to drag and drop those folder in here. And I'm going to put that. So I need to do it as an admin. So I need to put again my folder, my password, it's fine. And I'm going to do it for all of them. Keep going. If you want, you can check it. If you remember, in include I think it was in include, I have QuPath.h. It's there. So it seems that it worked fine. So now that should work fine. Alright. Alright, so now that QuPath are well installed, now we can install Cellpose with the GPU. So to do so now, as Anaconda was installed, we can run an Anaconda prompt. So if I go to the starting panel, if I type in something that starts, so like Anaconda prompt, I'm going to open an Anaconda prompt. And the first thing we're going to do is to define a virtual environment, which is extremely important whenever you do some Python, because if you install something on your base environment, then you're going to have lots of problems with different conflicts. The packages we use, they are updated so on a daily basis, or maybe not daily, but quite often. And so if I run something today, that might not work in a few months, just because the packages will have evolved and they might have some conflicts between the packages. To make sure everything is working fine, I can define a virtual environment and install everything I need, and then when this virtual environment is activated, it will always run the same way. So it will always work until your computer crashes, which is extremely powerful and really the right way to do Python. So I'm going to start by defining a virtual environment. So I'm going to put it in the same folder than I did it before. So in previous video where I show how to install Cellpose, but without the GPU, just the CPU. So I put it in the D in work. I have here Cellpose off. So I'm going to create a new environment for Cellpose with the GPU. So what you can do is that I need to go in that folder. To do it simply with Windows, I can hit Shift, right click, and then copy as path. As it's not in the same drive, I need to first write in the drive. So it's going to be D-. Alright, now I'm in D. I can write in CD for current directory and then Control V, and I'm going to go exactly where I want to go. And now I'm going to create a virtual environment, and I'm going to use the venv environment with Python. To do so, I'm going to type in Python -m venv in the name of my virtual environment. So let's say Cellpose GPU off. Alright. And now it's creating a new virtual environment, which is called Cellpose GPU off. Alright. I first need to activate it. Very important, because I'm still not in my virtual environment. So if I go to Cellpose GPU off, and then scripts, and then activate. Now it's activated. So now I can install Cellpose. Before installing Cellpose, I'm going to install PyTorch with the GPU, which is really important to actually run Cellpose with the GPU. So I'm going to go back to my web browser, and so Google. Alright, it's not. Yeah, here. Alright. So if I look for PyTorch only, then I can go directly on the PyTorch website. And the great thing with the PyTorch website is that if you go down here, you have everything you need to install PyTorch the right way. Which is really nice, because it's going to give you the actual command line you need to install PyTorch with your GPU. So here we want obviously a stable version. With Windows, we're going to install it with pipe. For Python, and we just installed QuPath 11.7. So here we have everything we need. We can just copy and paste this command in the prompt. We are in the right environment, Cellpose GPU off. Alright, so let's install this. So now you see it's going to download everything that's needed to install PyTorch with QuPath 11.7. So it's going to take a little bit of time. When it's downloaded, it's going to install everything. So I'm just going to speed up video so you don't have to wait for the downloading and installing time. Alright, now that PyTorch is installed, we're going to install Cellpose by just typing in pipe install Cellpose. So it went quite fast because I already downloaded everything with the previous environment. So if you do it for the first time, it might take a little bit of time, but that should be similar to what it did for PyTorch. I'm going to start downloading or something like this, but more, more lines, and then it's going to install everything. So now it should be fine. Now we want to use this with QuPath. So to use it with QuPath, we first need to actually install the Cellpose extension for QuPath. So you can type in something like this, QuPath Cellpose extension, and you can then go to the GitHub page released by Biop. Biop is a imaging core at the EPFL, and this is actually, I'm gonna go on, so you might arrive on that website, actually on that page, and you want to look for the latest release. Releases are here. You can just go to latest and then download this zip file. Right, it's pretty small, so that should be fast. If I go to my download folder, here I have the QuPath extension. I'm gonna put it on my desktop. If I unzip it, I have two files. A Python file, which is useful if you want to train or retrain a Cellpose model, which you can do within QuPath. So that's actually pretty neat. But we won't do that in this video. We'll just use QuPath, and that's the file which is required, the jar file. So I'm going to start QuPath. Then I'm going to open a project. I have one here. And so in this project we have several folders. In blue we have type 2A fibers. In green type 2B fibers. In red type 1 fibers. These are all muscle fibers. And then we have laminin, which stains the basal membrane that surrounds muscle fibers. So with laminin we can actually look at all the muscle fibers. So here the idea is to use Cellpose not to segment cells but to segment muscle fibers. I'm going to define an annotation in here, for example, and then I can run Cellpose. So before running it, I need to install Cellpose extension, so I can just drag and drop QuPath extension Cellpose in here. I already have it, so I'm not gonna put it again, but if you do it for the first time, and it's just gonna tell you that you have Cellpose extension that's been added in a comment at the bottom right of your screen, and you can check if it's been well installed. If you go to extension and install extension, then you're gonna find something which is called Biop Cellpose extension with the version next to it. Alright. Now, you still need to tell QuPath where Cellpose environment is so it can run from it. The extension is just a bridge between QuPath and the Python code of Cellpose, which tells, okay, you want to segment this, so it's going to take the image, tile it, and then for each tile it's going to call QuPath in a Python environment. So to do this, we need to go to Edit, Preferences, and here we're going to have something Cellpose. So we need to tell which environment type we used. So there are several options, but we actually defined a VENV Python environment, virtual environment. So we're going to select this, and then we just need to tell where the environment is. So if I go back here to my folder, so it was in work and Cellpose GPU, I can do a copy as path with shift and right click, and I can copy it here. The only thing you need to do is to remove the quotes. Alright, now it's in the right folder. I can run Cellpose in QuPath, and so you need to actually define a script. So you can go back to the web browser. On this website, you actually have scripts. When you go down, you can also go to my GitHub page, tpcat GitHub, where there's one about the training I give about QuPath. If you go there, you have scripts, and in the scripts you have something which is called muscle fiber detection fluo. And so you can copy and paste in a script editor. So if I go back to QuPath, I can open the script editor, show script editor, and I can paste it in here. If you look at the different parameters, so here you define the model you're going to use. We're going to use the pre-trained model, site 2, pixel size, channel. So here we're using channel number 3 because we start at 0. So if we go back, just let me show you the channels. This is channel 0, this is channel 1, 2, and 3. All right? And then normalization. So this is nice because now normalization is down at the slide level, not time per time. So it's gonna give you better results. The threshold on the probability for cells. So just be careful, it's not between 0 and 1, as you can see with starlist, for example. But here you can have negative values down to -8. And I think you can get up to 16. It's a bit weird, but that's how it's been designed with Cellpose. Flow threshold 0.4 is the default value. Diameter of your fibers, so here I know I need to increase a little bit. You can do expansion. Here we don't need, because we just want to have muscle fibers. We don't have markers that are outside, so it's fine. And then this is to extract measurements related to shape, related to intensity. And then that should work. So the first time you're going to run it, it's possible that the pre-trained models are not actually run. So I'm going to try it. And just to see, I think as I installed it in another folder, it's probably going to work. Yeah, so it's directly working. And so I'm going to kill it. Just to show you a few things. So first, it says touch CUDA using GPU. So the GPU install worked well, which is great. And then it's directly running here, finding mask and everything. Tells you that it's been split. So it did, part of it. It's been split into 4 tiles. All right. So as I told you, first time you're going to run it, it's possible that it won't work just because pre-trained models are not downloaded yet. And so Cellpose is trying to run a pre-trained model but can't find it. If it's the case, so if it doesn't do anything and you have an error at the end of your script, it tells you which command it's running. Here it's saying executing command, and it just say this command should run directly if copy-pasted in your shell. So you can copy the entire line, or you can just start from there. So without the command .exe and /c, you just run everything there, copy and paste in your prompt. And when you do that, it's gonna run. So here it got the image, so I need to enter it, yes. So it got the image, it split it into 4 tiles, and now it's running each tile independently. And so if the pre-trained models were not downloaded, when you do that, it's going to start by downloading the pre-trained models, and then it's going to run everything. So I can now close that, I can run it again, and so it's going to take the exact same time. So as you can see here, it tells you where it put the the tiles, so it's in a temporary file in your project folder, and it's running. And as you can see here, it just takes 2 to 3 seconds to run it. It's much faster than with a CPU. It's about 5 times faster than with a CPU. With the GPU I have on my computer, as you can see, segmentation looks pretty good. Now we're gonna do the same thing, but for using Cellpose within Fiji. So I'm gonna reduce that. I'm gonna open Fiji. And so you first need to install a plugin that's been designed by the same guys at BIOP, at EPFL. If you go to Help Update, so I already did it, so the plugin is already installed, but I'm going to show you how you can install it. So everything is up to date. If you go to Manage Update Sites, you need to check PT BIOP, this plugin. So as you can see, it's BIOP at EPFL. So this is the plugin that lets you run Cellpose within Fiji. So it works. So if you haven't installed it, you can check it, close it, apply changes, it's going to install them, and then you're going to restart Fiji, and when you restart it, you'll have this plugin, BIOP, and this is Cellpose. So you just need to do the same thing that we did with QuPath to tell Fiji where your virtual environment for running Cellpose is. So if you go to Cellpose Setup, of type is VENV, and now I'm going to define Cellpose GPU of as my virtual environment directory for Cellpose. Everything is fine, and just define version. So I didn't explicitly tell which Cellpose version I installed when I did the pipe install, but it's the 2.0. It's actually a 2.2, something like this, but it's after 2. I'm going to say OK. And if I go back to my QuPath project, you have this temporary folder, Cellpose temp, and that's where QuPath actually store the tiles from the project. That's how it works. It tiles your annotation. So here it was tiled into 4 different tiles. Run it for each of them, get the mask, put them together, and then put them together in your QuPath. So I'm going to open this image, and I'm going to run Cellpose from Fiji within this image. So if I go back to plugin, BIOP, I have Cellpose and Cellpose Advanced, and here I'm going to define the parameters. I'm going to use the same 100 for the size. Everything is the same. Let's say default 0.4. Alright, I'm going to use a Cyto2 pre-trained model. I don't have a channel for nuclei, just have a channel for cytoplasmic marker, membrane marker more here, which is not actually that. It's for muscle fiber, but it's fine. It works for what we want to do. So I can just run it. And it's running, and when it's done, it gives you a label image with the labels for each object. Which should be done pretty soon now. Yep. So this is label image. You can change it to glass B and dark, for example, so we have a different color. So we see we have small regions that are also so clearly here as it's under segmentation, probably because we don't have the entire fiber. We see that this happens on the border. So we could definitely filter out these regions by using MorphoLibJ, for example. So great thing here is that we can run Cellpose within macros fairly easily. Something that is nice too, which is in the same plugin, is that you can actually define ROIs for your label from your label images. If you go back to BIOP image analysis raw, you have something which is called label images to rise, and so it defined a region of interest for each label image, so I can have a different ROI on my original image, for example.